Thanks for attending the session today. I'm Sheryl Sage, and I work for Redis Labs. I'm based in the Bay Area, and Redis Labs is actually based and split between Mountain View, California, and Tel Aviv, Israel. And our founders are actually based in Israel. So today, I'm going to talk about extending Redis to real-time streams processing. And I was in the tail end of the last session, and there was a lot of 300, 400 level questions that came up. So I want to preface this with this is more of a 101 or 200 level introduction. And I am definitely not the technical expert behind this, but I'll try to give you what you need to get started, and then also point you to some good resources as well. So we're going to cover today a little bit about why data streams are important, what a typical data stream looks like, the challenges that you face with them. We're going to go into Redis streams and how it addresses the challenges. And then I'll go through some of the commands. I probably won't break into the terminal window, but I've got some good examples I can take you through. You'll get a good understanding of how to get started building Redis streams. And also I have a nice demo, and I'll direct you to GitHub for that so you can get the code so that you can play around with it as well. So before we get started, how many of you have used Redis? Okay, leave your hands up if you use Redis as just a cache. Okay, leave your hands up if you use Redis for something other than caching. Nice, okay, awesome. So for those of you that didn't raise your hand, I'm gonna just go through a few introductory slides. Apologies to people that are super familiar. Redis is the leading in-memory NoSQL database. And if you aren't familiar with Redis, it's pretty popular, 2 billion downloads from Docker Hub. Most recently, I learned from a partner that in their State of Modern Application Studies that it actually surpassed MySQL as the most used database on AWS, which is pretty amazing. Now, Redis Labs is the commercial company behind open source Redis. There are a lot of flavors of open source Redis that are out there. Salvatore Sanfilippo, the creator of Redis, works for Redis Labs, and we support the community. And we also have an enterprise offering for companies that are taking Redis into production. So first off, why is Redis so popular? And there's no doubt about it, it's performance. Redis is able to perform the most operations a second with the lowest latency out of all databases. Now, the study that you see here on the left is from a third party, Avalon Consulting, but there's been many benchmarks in the past, and you can see that we stand up rather well against Aerospike, DataStax, open source Cassandra, and Couchbase. Now, the second reason why Redis is incredibly popular is that it has very simple to use pre-built data structures. And the thing that's so great about this is that, and if you're familiar with Redis, and there's always confusion about this, in a traditional database you have tables and you have two-dimensional views to the data. And when you load data into, when you're an application developer and you're actually loading data into an object to relational mapping, you have to specify where that object and where the data is going to go. And in Redis, you don't do that. You skip that step. You store the data naturally in Redis in the data structure that you specified. And that's one of the reasons why it's so fast. The last area is really around extensibility. And Redis has a modules API. And some example modules that have been built by Redis Labs includes our Redis search modules, Redis graph. There's also a brand new Redis time series module. And there's been a machine learning module and a Bloom module for quite some time. So you can extend it yourself, and you can run natively within Redis if you build your own module. So since a lot of you just use Redis for caching, I want to give you a sense of what you can really do with Redis. So Redis has these Lego building blocks, right? And you can build queues and job queues, and you can build session stores and geo-distributed session stores, leaderboards with sorted sets. There's with geospatial indexes, you can do a lot of the location-based services that I'm sure you all used on Lyft and Uber when you came over. So Redis is really powerful. And I would encourage you to play with these commands because they're also incredible. It's very simple to use as well. So for a standard web app, what you might find for folks that haven't seen this is you'll see Redis as like a look-aside cache or a write-through cache. You'll see Redis as a user session store, so you save your session state, whether the user is online or offline. Shopping carts are a great example if you haven't seen it. And that's stored in a user session store. And those can be globally distributed as well, so you can do a geo-distributed session store. Jobs and queues, super popular, and we're going to build a little bit on lists and sorted sets and pub/sub as we go through the rest of this session. And then search is another common one that you would plug right into your web app architecture. And some of our customers are actually using Redis as a primary data store. And it's pretty powerful when you start using Redis on Flash with SSDs. You can really cut the cost of your Redis deployments. But there's many things you can do. Netflix does rate limiting and error detection. There's unlimited use cases that you can start to apply Redis to. So since I work for Redis Labs, I have to kind of give you the full story here. I think I covered the core, so that's open source on the left. Redis modules, you can see a lot of those have already been created. And what Redis Enterprise brings is linear scalability, high availability, active-active for geo-distributed applications, and things like tiered memory access. So we work with Intel Optane persistent memory. It's pretty powerful when you have really, really large data sets. So we have a customer that's trying to scale up to 1 petabyte. And when you're in those kinds of situations, that's really helpful to have that Optane persistent memory support. But since this is kind of a technical audience, Redis Enterprise technically sits above your open source nodes here, are your open source instances, and it brings you a nice UI. You have a RESTful API that you can use. The cluster manager is really powerful, and so if you haven't played with it, you can get a free trial out on Redis Labs and start playing with the cluster manager because it just makes scaling open source Redis so much easier. And then we also have a proxy manager that really is behind the scenes improving the application performance as well. And it's delivered in any form, any cloud, database as a service, downloadable software. We have a Kubernetes operator, and it works with Pivotal container service. It works with any Kubernetes service that the cloud, if you're using GKE, it's going to work with that as well. And of course, we support PCF and Bosch, and we have quite a few customers that have been running that and have been happy with that solution. So now I'm going to, now that you all have kind of a shared understanding of Redis and Redis Enterprise, I'm going to jump into data streams. And to give us just kind of a baseline, in its simplest view, a data stream is just a data structure here, and it's going to connect the consumer with the producer. But usually you have many consumers and many producers. So it gets to be kind of complex. But in its simplest view, you have 4 main components to a data stream. You have the ingest, the message broker or streams processor, the output stream, and you have an analytics engine. Now, many of you have message brokers that you use. You use RabbitMQ, you use ActiveMQ. Those are great tools, no problem with that. But what the idea here is that with the data stream, you're going to be collecting high volumes of data, and you can have no data loss, and you need to store that data temporarily. On the output stream, you're going to have push that to the consumers, and you need to have a plan for real-time data, but historical lookups as well. And with analytics nowadays, there's kind of this trend to converge and to bring real-time analytics into your streams processing. So those are kind of the standard capabilities in most IoT or social sentiment applications. They're going to use all of these components. So the good news is that Redis Streams was released at the end of last year. And Redis, is able to perform all the functions of a data stream. So there's a data stream structure, but you can also go with other capabilities that you're comfortable with. PubSub is a tool that many people are familiar with. And if you're doing like a Slack-style chat application, it might make sense to stick with that. Now we also have a lot of connectors that exist, and you can connect. And there's a lot of capabilities around analytics with now, in addition to search and graph, there's the time series module as well, in addition to just what the core offers. So now we're going to look at the challenges of managing streams. And the first challenge is to support a variety of consumers. So you're going to have real-time messaging, you're going to have periodic lookups and batch processing that you need to support. And the idea is that your streams database should have enough features and capabilities to do all of this. But the second problem is the catch-up problem. Your producer will likely produce at a faster rate than your consumer can consume. So in this case, I have an image processor, and the processor is producing images at 500 images a second. The consumer can only process 100 images a second. So you end up with a backlog. Now, you can address this problem with having multiple image processors, but then you end up with new issues. You need to think about how those image processors are going to process the messages. Can you handle scale and mutual exclusivity between them? And the second thing is, what if an image processor goes down? What happens to the data? And does the other image processor know how to pull that data? So the third issue is connection failures between the producer and the data stream, and the image processor and the data stream. So the solution needs to also be resilient to failures. So Redis Streams. So for those of you that know Redis Streams and have used PubSub, it's a lot like PubSub, but it actually comes with data persistence. So in a PubSub scenario, you're going to have a publisher of a channel, and you have many subscribers. And if they're online, that's great. If they're offline, it's a fire and forget solution. So there isn't persistence there. So Redis Streams fixes that. And it's a little bit like lists, but in the case of lists, you have a separate list. And that separate list you have to manage with separate subscribers. And you don't have to do that with streams. With streams, you only have one copy, and you manage all of your consumers with that. And it's a little bit like sorted sets, but that's synchronous activity, and streams will allow for asynchronous communication as well. So if you're familiar with Redis, you can kind of do a lot of these things already today. But with Redis Streams, we remove the limitations behind those. So just a quick recap. There's asynchronous data exchange between a producer and a consumer. You can consume the data in real time, and you can do lookup queries. With consumer groups, you can scale out and have mutual exclusivity of the data. And you can handle actually very robust, complex scenarios that are handled through consumer groups, which we're going to go into in a little bit more detail. So Redis Streams is simple to use. There's one data sheet on Redis Labs site that I'm going to recommend for everyone in the room that wants to play with it, because on the back side of the data sheet, it has every single Redis Streams command and how to use it. It's actually not really a data sheet. It's more of actually a technical, useful, quick reference guide. So definitely take a look at that. Okay, so first off, how do you add data to a stream? So there's a really simple command called xadd, and in this case here, let's see if my pointer works. No, it doesn't. So there's a xadd, and you can name your stream my stream, and the star means Redis Streams go ahead and identify it with your own internal identifier. Then you add your own name value pair. So in this case, I'm going to add a lot of names to my stream. But you can see how simple it is to just add a really simple name in there. And when you read the data, there's a command called xread, and that xread also has a blocking option. So you can do asynchronous message transfer with that, and you can kind of test out that blocking command and see if that works well for you. So to look up a stream, you'll use an xrange command with like a +, and then it'll just dump out the entire stream, and you'll see that your xadd added someone to the list. And with xrange, you can also limit the output, so you can give it a count, and you can also do a reverse, an xrevrange as well. And it uses radix trees, so this command is super fast. So I think that the power of Redis actually is really well seen when you go test out and try this command. So one of the most important things to get out of this session today is how we work with consumer groups. Consumer groups are what makes Redis Streams really powerful. So going back to our image processor example, let's look at how it works. A consumer group is structured in this way. Every image processor in this example has a consumer that's associated with it, and every consumer has a separate list. And that's all done within Redis Streams. So you don't go and create your own list. You can do it automatically. The consumer group creates the list, and then there's also a unconsumed list of messages for that consumer group as well. Oh, go ahead, take the picture. Okay, awesome. So how do you create a consumer group? It's pretty easy. It's a xgroup create command, and and here what I'm doing with this command is you just do xgroup create, you name your stream, you name your group. The $ says start the messages from this point, and MK stream is super powerful. So if you don't have a stream, Redis just creates the data stream on your behalf. In this example, we have some messages, right? And it's A through E. And what's happening is when you do the X group create, it copies a reference of the message to the list. It is not copying the actual message. So it's going to be much faster. There's no message copy that's happening here. So in this example, you're consuming 2 messages at a time. You've got Alice, you've got Bob here. And you can see that it's a mutually exclusive list, and the remaining message on the queue, it remains in the unconsumed status. So after Alice reads her messages, she does an exac, and when that happens, those messages are going to be removed from the list. So this is important because then you can go ahead and repeat the cycle with an xread group and read more data in the list. App A goes back and pulls the remaining message from the unconsumed list. So what happens when app B goes down? The good thing here is that app A just steps in and processes the pending message. And the way it does that is with an xpending command. So you use xpending all the time. It runs in the background, and you can see all the messages that are in the list. And you learn that the consumer is not consuming with a timestamp. And so in this case, it's set to 10 minutes. And then you run an xclaim command once that timer has been set. So this is kind of the 101 basics of how to use the streams, the Redis streams commands. And some of the Redis clients that support Redis streams are out on GitHub. So take a look at that. And then, so I mentioned at the beginning that there's a social media analytics demo. It's on GitHub. One of my colleagues who was actually supposed to be here today wrote this. It's fantastic. And I'm going to take you quickly through it so you get a sense of what it is, but then you can go ahead and look at the code on GitHub. So there's a Twitter ingest stream that we're going to kick off, and then there's an influencer classifier consumer that's going to kick in. And what it's going to do is it's going to tag the influencers. It's going to do some processing of those and identify in a leaderboard who are the top influencers that we have been ingesting. So let's see if it works. Okay. So Roshan has all of his code out here on GitHub. So at the end of this, I'll make sure that it's in the slides so you can pull that out. But you can see that the streams are starting up here, and it's just pulling and ingesting those in using Redis streams. And then we're going to kick off the influencer classifier, and it's going to start to consume and then update with new influencers, and then update the leaderboard with the latest information. So this is one of the more real-time examples, but you can do a lot more capabilities, even with historical lookups as well with streams. So with that, I think, I'm not sure if we're out of time, actually, but I'll open it up to questions. And if I can't answer your questions, I'd be happy to get an answer to them. Yes? So I think we need to identify what you mean by back pressure a little bit.
Slowing down the producer.
Oh, I'm going to have to double check on that. So definitely reconnects, and it can fetch back the data. If the producer, if the connection is cut off, it will reconnect, and you won't have data loss. So I'm not sure if that would help answer the question. So it might. Yeah. Uh-huh.
Can you tell us more about the use case when people are using Redis as a primary data store?
It's used at a few financial services companies that are actually here this week as a primary data store. They encourage their staff to try Redis first, and if it doesn't work, come to them. I've seen it used with a Canadian customer, actually as a downstream primary data store for Kafka even. And that was really surprising to me, but yeah, they chose to stick with what they had, and then they wanted to just plug Redis in there. It's more frequently, of course, put in front as a session store, or to offload your MySQL or your relational database with inventory management. But yeah, it can be used also with Kafka as a primary data store. Yes? Does it support queuing? I mean, it supports queuing in a very different way. So, your job queues that you do with sorted sets, lists, and pub sub, those are the standard ways to do queuing in Redis, job queues in Redis. And so when I was explaining that, it basically solved a lot of those limitations. But generally, a queue, you would use a sorted set for that, or a list, right? What's that? Okay. Okay. And if you need clarification on that, I'm happy to get back and confirm that. Okay, if you have anything else, come talk to me after. Thank you.